Ladies and gentlemen, good evening, not evening again. Ladies and gentlemen, good day and welcome to another session of Digital Revision Program. I am Mr. Nambane, and today we'll be looking into capacitance and electric circuits. Excuse me. I am aware that we will not be having most schools or learners in today's session. The reason for that is I'm aware that tomorrow morning most schools will be writing uh, home languages, either a SAL or first additional, but majority of people will be now writing language. So it's known that everybody uh, is doing now our languages. So what I am going to do is going to be very easy. I'm just going to keep you for about 45 minutes maximum or even less. However, the recording will be available later on our YouTube channel for those that could not manage to be here with us. Ladies and gentlemen, without wasting any time, let me just remind you that we also have about 3 to 4, 5 sessions of the digital revision programs that we have already been uploaded on our YouTube channel. Feel free to watch, feel free also to subscribe there. I can already see that there are people also watching from YouTube also. So it basically says we are now in the right platform for us to start. Ladies and gentlemen, without wasting any time, let's look into capacitance and just quickly remind ourselves what is important here. Ladies and gentlemen, this will be around, let's say, capacitance. Capacitance. Sorry, in an exam, this will be plus minus 9 marks. It will depend on the examiners, but in most cases we anticipate that it will be around 9 marks. However, there are only two important definitions that one must worry about. And these definitions, ladies and gentlemen, is a definition of a capacitor and a definition now of capacitance and capacitance of a capacitor. So these two are the most important definitions that now each and every one of us must now worry about, because it's already the 2 marks. So what does it say to me? It says now, if this is 2 marks, the 7 marks must be sitting somewhere. Where is the 7 marks? The 7 marks will be now the application thereof. So it means 2 here, it will be the use and the application thereof. That is now very important, ladies and gentlemen. So this will also be around plus minus 7 marks. But now this is made easy for me to know what equations I am going to use. So when I look into my formula sheet, ladies and gentlemen, it is easy to see that the most important equations, it's C is equals to permeability area divided now by D. So what does that say to me, ladies and gentlemen? This says to me it is important that I actually understand how this equations works, because it can either be any of the two or any of the three thereof. So let me just maybe explain what needs to be done. First thing, a capacitor is a device, very important, a device that stores electrical charge. Electrical charge. Then capacitance, the only difference now between the two is that capacitance of a capacitor is the amount of charge that it can store, that a capacitor can store, that a capacitor can store per volt. So these are those ones of complex questions when we are exposed to defining a capacitor. In this time around, the examiners are now going to somehow ask us to explain capacitance. Why? It looks a little bit complex in a sense that there's this part that majority of us as learners we forget, that it is now just the amount of charge that a capacitor can store per volt. That is very, very critical, because that is where now we will be losing our marks. And remember, for definitions, ladies and gentlemen, it is now 2 or 0. So let's ensure that with capacitance we are able to get now the maximum marks thereof. Ladies and gentlemen, we are used to words or questions with statements. However, I have selected this question 7, because now it is a graph. The error analysis, the diagnostic report shows us that us as learners, we are failing to interpret the graphs. We are failing to use the graphs to perform necessary calculations thereof. So this is also to say, let's close all the gaps of possible questions that might just appear in an exam. It could have been an easy question with a smaller circuit, but this one will be more valuable because it is something that has never been assessed before, or it has been assessed but now the answering thereof was a little bit poor. So it says let's expect some form of a graphical representation of now what? Of the exam itself, of the section of capacitance. Ladies and gentlemen, 7.1 is clear and straightforward. It is a definition. Definitions are non-negotiables. Capacitance is the amount of charge that a capacitor can store per volt. It is not asking about capacitor. A capacitor is a device that stores now electrical charge. Very, very, very important, ladies and gentlemen. Let's differentiate between the two. Let's state and give what now the examiners are actually asking for. Without wasting any time, the graph below represents the results of an experiment that was conducted by a learner using a capacitor. The learner measures a charge stored in different potential differences. So I am given a charge, I am also given a potential difference. Now listen to this at 7.2. Use the results on the graph to calculate the capacitance of the capacitor in this experiment. Ladies and gentlemen, it says here, if I can choose any point this will represent the gradient. This will be the charge, and this will be now the V. So is there an equation that I can use that will assist me in order for me to be able now to exactly know where am I in the graph? Ladies and gentlemen, we want now the minimum or the maximum charge that can be stored by this capacitor. So because of the equation 7.2, because of the equation C is equals to Q over V, it says to me I will need to have values now that will be now assisting me in terms of the potential difference as well as the charge. Ladies and gentlemen, it can be any point, but remember it must be now between 2 points because we want now the average capacitance of the capacitor. So what I'm going to do, I'm just going to make it easy for myself. I am just going to choose a point where my charge, my V is 2 and my other V is 4. Then I can easily read there on the graph to say in actual sense I am working with a charge that is now 10 and I'm working with a charge that is now 5. Excuse me. So this makes it now easy for me to work with small values, and I can easily punch that in my calculator. So this will just be, ladies and gentlemen, is equals to 10 minus 5, and this is now 4 minus 2, and the final answer will be given as 2,5 farads. Ladies and gentlemen, farads is the correct SI unit. But remember, it can be any coordinates in the graph. So you can decide to choose 2 and 5 and then use the 8, because when you check here, this line is a straight fit, it's a perfect fit, so any value or any two corresponding coordinates will definitely give you your 2.5 farads. But it is important to understand how to operate with a graph. At 7.3, what is now the relationship, that is 7.3, between the charge 7.3 between the charge and the potential difference? But I can easily see and read that when the potential difference is increasing, the charge is also increasing. I am trying to avoid that they are directly proportional to each other, because we tend to use that weight everywhere when we are asked or expected to explain the relationship. At times it's just that the other one increases, the other one decreases, or they both increase. So we can easily say as charge increases, the potential energy, the potential difference increases. It will be easy to see that. But if you have time to check, it's increasing with now the same increment: 2, 5, 4, 10, 6, 15, 8, 10, 20, then 10, 25. Is then that we can say they are now directly proportional. Why are they directly proportional? Because for every increment of potential difference, the charge now is also increasing with the same amount of increment. So I'm just going to say as charge increases, as charge increases, comma, potential difference also increases. Potential difference also increases. Yes, we can accept it. Charge is directly proportional to potential difference. Yes, we can accept that. So this will be just now your other 2 marks. Ladies and gentlemen, it should not be that complex. The only thing that is left now, the only thing that is left is for us to say, okay, fine, let's answer 7.4. Then when you answer 7.4, it says give 2 examples of capacitors used in technology. 1, they are used now in filter circuits. They are used in filter circuits in power supplies. The other common one is they just now separate the frequencies between a subwoofer and a bass, or a tweeter for that matter. So they just now use to separate a bass from the tweeter. So what it does, it basically separates now your lower frequencies against your higher frequencies. So it's important maybe to say separates the frequency, as now that is the keyword. Frequency of bass and that one of the tweeter. Maybe just to add another one, it works as a power factor correction. Power factor correction. What does this mean? It means it just regulates the amount of power, or it involves now the electrical transmission of the system. That is what it basically does. Now, ladies and gentlemen, we have used C is equals to Q over V. We have explained the relationship between the charge and the potential difference in a capacitor. We have explained the difference between a capacitor and capacitance. The only thing that we need now to be doing is actually the use now of the equation C is equals to E naught A. C is equals to E naught A divided now by T. Ladies and gentlemen, this is another equation that we expect the examiners to give to us. Very one of the important equations. But the only thing here is that when you work with this equation, it's important that your area is in meter squared. Your D, it is now in meters. Then it will be easy for one to do that. Very important. So let's just say fine, let's just check the units that are given to us. Very important. So ladies and gentlemen, this looks like an easy 9 marks, but if we do not prepare accordingly, then it basically says we are not going to be able to do it the right way. So this is basically it with capacitance, and we used a graph, but majority of the questions will usually be a small circuit or just a statement that each and every one of us will be able to work with. Ladies and gentlemen, Let me give you your 50 seconds for you to digest everything that we have spoken about, and then we can quickly go to electric circuits. Ladies and gentlemen, thank you very much. Let's go straight into electric circuits. With electric circuits, ladies and gentlemen, the key thing is understanding the general operation of the circuit. Basic definition or laws are there, but I'm expecting something around Ohm's law. Why around Ohm's law? Because it will support SUA, state, use and apply. So I am expecting also to have the same structure as this one here. If not, then it will basically say it will still be the application of Ohm's law, but now with a different definition. But all the equations we have, ladies and gentlemen, are equations that are applicable either when using Ohm's law or when using power. Others now relate to the energy that is being dissipated or the work done by either the resistor or the work done by the bulb in terms of the brightness thereof. So what we need to be on the lookout is which definition is more critical, it's more applicable. So the very first one, ladies and gentlemen, should be the use of Ohm's law. That will be very, very, very critical. So now one will ask, how best can I apply all these equations of electric circuits? The first hint will be, one, follow the current path, comma, this must include the variable asked. Maybe it will be wise if I take it up here and say this is what needs to be done. Follow the current path. This must include the variable asked. What does this mean, ladies and gentlemen? This means that when I am given a circuit like this, and I am at 821. And the question says calculate the total resistance of the circuit. It means I must include everything which is a resistor here. Why? Because this means this section of parallel plus the section of series must give me the total resistance of the battery. Not of the battery, sorry, but of the circuit, because we are told that ignore the internal resistance of the battery. So this is a way of me trying to say where am I in the circuit. Now to answer that, it will be easy to say fine, I am at 821. So for me to get the total, it basically says R total must be equals to R parallel plus now RS. I can easily see that I have included the section in my follow the current path. However, this resistor is also within the path as well. So what needs to be done, ladies and gentlemen? I will need to calculate separately 1 over Rp of R1 over R2, and this will be now 1 over 4 plus 1 over 2, and Rp, ladies and gentlemen, it will give me something like 1,330. Just note and remember, you are going to get a reciprocal. Then you must just now switch and divide with the other one that you have got. Because remember, the equation, ladies and gentlemen, says now what? 1 over Rp. Then it is easy to say Rp is 1,33 plus the Rs, which is 3. This will give us 4,330, and this now becomes the total resistance of the circuit. Now when we are at 822, can we try and do the same procedure of following the current path? And this must include the asked variable. So the variable that they are asking us now is calculate the reading on the ammeter. So what must one do? Very easy, ladies and gentlemen. We follow the current path. It divides yes, and then it goes now into there. But what does this mean? This means, ladies and gentlemen, the very same current will also pass throughout the battery as well. When it passes throughout the battery, one can easily say, I have now my V total. And what is my V total here, ladies and gentlemen? My V total is just 12V. So when I want to go and calculate the reading of the ammeter, I must now use what? The total resistance of the circuit. Because when I check, the current passing at 3 must be the total current of the circuit. But the current passing at 4, because it has now divided into 2, it cannot be the total current of the circuit. Now let's quickly do this. At 822, V, okay, according to Ohm's law, R is equals to V over I. 4,33, V is 12, I is the unknown, and then I, when you do the mathematics, 12 divided by that, it must give you 2,778. So what is this 2,778, ladies and gentlemen? It is the current passing at the ammeter reading. So what does this say? This says, ladies and gentlemen, the current passing at 3 ohm, it is also 2,77 amperes. The current passing there, it is also 7,77 amperes. However, this current here, when it gets to this point, it will now split into two. So what can one do? Very easy. What can one do is just to say, fine, ladies and gentlemen, I am now at 8.23. The question says calculate the reading on the voltmeter. But let's check where the voltmeter is, ladies and gentlemen. If I want to calculate the voltmeter reading here, it means somehow if I can calculate the current passing at 2 or the current passing at 4, I will be able now to get the voltage here. Why? Because in parallel resistors, V total is equals to V1 is equals to V2. But in this instance, we do not have only the parallel combination. We also have now the V of the series section of the cell. So what must we do? We must just say now total V of voltage, the one that is now 12, it's actually V total plus V parallel plus now Vs. So what does this say? It says if V total is equals to Vp plus Vs, is there a way of me getting the Vs? Yes, there is a way. Then I must say I am at now what? I am at 3 ohm resistor. What do I have? R is equals to 3 ohm. The current passing there 2,77A, then I can easily get the voltage there. What must I use? Very simple. I must use now Ohm's law and say R is equals to V over I. This will be easy to say 3, we want V and then 2,77. Then we get V of parallel of series as something like 3,68 V. Then we can now go back and use this now understanding of how a circuit operates. Why? Because remember, we have the basics of circuits in parallel and the basics of circuit in series. However, we cannot include that in the discussion because it's things that we do at grade 8, grade 9, grade 10 and grade 11. So this means now some and each and every one of us should be able to understand exactly how a circuit operates when we have a connection of parallel and a correction of series only. So this becomes easy, ladies and gentlemen. 12 is equals to Vp plus now 3,68. Then when you do the mathematics, Vp is just equals to 3,69. Just need to get my calculator. Please check me on that one. 3,69. Please verify my calculation thereof. Or maybe I do not have a calculator near me, but now please verify me on this one. It's very important. But 2,37 cannot be that. Let me quickly correct it, colleagues and learners. Let me quickly correct it and use a calculator and stop imagining, because this is now the mistake that we will do in an Excel. So let me quickly do this and say 3 multiplied by 2,77 is something like 8,31V. Then 12 minus 8,31V is equals to V parallel, and V parallel is 3,69V. Please use a calculator. Don't do the mistake that Ntate Nambani has just done, because now you will be losing majority of your marks. Thank you very much. Now let's go to 8.24. At 8.24, calculate the power in the resistor 3 ohm. Now what do I need? I just need to go to my formula sheet and just check what is it that I have. It's easy. I have the V, I have just calculated it, and the current, but I'm just going to use the 3 ohm and the current calculated, because those ones I am somehow confident with them. Then it just says now P is equals to I squared R, and then this becomes 2,77 squared multiplied by 3, and the final answer, ladies and gentlemen, becomes something like 23,07 watts. Very, very, very important. And lastly, it is 8.3 less. Sorry, ladies and gentlemen, I lost some connection there. Let me quickly go back. Yes. Now at 8.3, will the ammeter reading increase, decrease, or remain the same if the 3 ohm resistor is removed? Now let's check, ladies and gentlemen. What do? We go back to our route of follow the current path. I will still use green. I will still use green as our highlighter. But now what do? Instead of taking this route, we basically say the current will flow in that direction, not go into the 3 ohm. What will happen now? Very easy. What will happen is that I am only left with resistors in parallel. And when I am left with resistors in parallel, I only have resistors in parallel. And what does this mean, resistors in parallel? Decreases the total resistance of the circuit. Very, very important. So because of that, ladies and gentlemen, according to Ohm's law now, according to R is equals to V over I, if R decreases, then it means I will increase. So the correct answer here is increases. Why? Total resistance of the circuit decreases. This is now very, very important. Hence the first question was, understand, ladies and gentlemen, where you are in the circuit. Because of that, you will be able now to actually understand how the circuit operate on its own. So before attempting to answer, let's follow the current path. Following the current path will assist in terms of knowing exactly where you are in the question itself. Ladies and gentlemen, with that being said, let's meet tomorrow. Tomorrow 2 o'clock it will be maybe Holt doing light for us, and then I will come back also to do paper 2, organic chemistry, as well as electrochemical cells. Ladies and gentlemen, thank you very much for your support, and may the great Lord bless you and give you everything that your heart desires. Thank you very much.